I'm pleased to say we have Jason Halko, the chair of the Canadian Carbonization Research Association, amongst his other duties, who's going to give us a talk on halocarbon fluid as a replacement for traditional organic fluids in coal float sink. Jason, the floor is yours.
Okay, thanks so much, Bob. Good morning, everybody. Certainly a pleasure to be here, have the opportunity to speak with everyone this morning and see some old faces, hopefully meet some new people this afternoon and tonight over a couple of drinks. I see there's a camera going on back there, so I don't know if this makes it onto YouTube there, Mike. I hope this is on your feed next time I watch one of your presentations. Before I kick it off, I definitely want to mention and acknowledge, as I always do, the first gentleman that gave me an opportunity in the coal business, Ted Hanna. He hired me as a co-op student back in the 1900s. 95% of the time, I'm grateful for that opportunity. The other 5%, I guess, has left me bald and gray, but still love what I do. So anyhow, we're going to kick it off taking a look at halocarbon as a substitution, replacement for some organic liquids. So before we get into the details, just going to give just a high-level coal processing 101 overview. Really, when we take a look at coal samples, and these samples could come from exploration, coal seams as you're actively mining, stockpiles to confirm your quality. There's really simplistic way in the lab to give you an idea as to what your coal qualities are. So one of them first is the float sink test. And that's really taking a coarser coal size fraction. So in these tests, we're using 0.5 mil and greater, up to 12.5 mil. And really the principle behind this is just simply different densities between coal and mineral matter. So coal, as you guys know, is lighter, typically has a specific gravity of 1.3 to 1.7. And then the waste rock that we're mining with it, siltstone, shale, sandstone is going to be significantly denser, so like say 2.5 SG. And really what we do in the lab is just set up these different tubes or baths of different SG fluids, and quite simplistically, the light coal is going to, on the left-hand side at 1.3 SG, float to the top. Everything heavier sinks, scrape off the coal, and then you put it into the next bath. So typically we go in like 0.5 increments, but you can see here as the SG increases, you're going to get more and more material floating, and the heavier rock is going to be at the bottom. So all the material on the fine side, so less than 0.5 mil, really you separate it from the waste with flotation, froth flotation. And the basic principle there is that coal is hydrophobic, so it doesn't like water. So you're going to have a water bath. In processing plants, you're going to use stuff like kerosene, diesel, MIBC to help facilitate the coal floating. But really what you do is just agitate the water with air bubbles. The fine particles are going to stick to those bubbles, go to the top, scrape off the coal again. All the rock is going to sink to the bottom. So that's washing coal really in a nutshell. So when it comes to the fluids that we use to get the different SGs, the table's got a lot of information here, but this is typically what we use really internationally. Everywhere in the world has been using these fluids. Just before COVID, we were looking at alternatives for these fluids. So the two on the far right-hand side, the 3M products, we did some research on those two individual fluids. Long story short, 3M is no longer producing those fluids, so they're off the market. They're obsolete. I think the most important thing to look at is down here in the hazard rating. And primarily in column number 1, the PERC, go back to 2022, down in the US, the FDA actually has now highlighted this fluid as a significant health concern. There is evidence to show that it does give people who use this product cancer. So it's definitely in their sights. They're reviewing the details of it, but it could be banned in the US in the near future. And then if that is the decision they make, there could potentially be a ripple effect into other countries, and that product could be off the market. So as technical folks, it's certainly prudent that we look for a technically sound and safe alternative. Hence the work that's going on with this washability study. And that brings us to this Halocarbon 0.8 oil that's available on the market. So this product here, I'm just going to say PCTFE oil. It's non-toxic, it's non-hazardous, it's chemically inert. There is no special PPE that's required when you're handling it. It has a broad operating range that's suitable for all the SGs that we would use in the coal lab. You could store it at room temperature, doesn't evaporate, and its boiling point is pretty high at 133 degrees Celsius. So in addition to the typical float sink tests that we do in the lab for the coals, we also did this different procedure where we added 500 grams of the coarse coal into 1,000 mils of fluid. And we picked the 4 different fluids, which I'll show you on the next slide. So it was pretty simple. We took a photo of the fluid before adding the coal, let it soak for 5 minutes. Then we took a photo of the coal and the fluid. We removed the coal, laid it out to dry, and then finally we took a photo of the liquids after soaking the coal. So I'm not going to show you the photos of the fluids before because they're all clear. And I'm not going to show you a picture of the coal getting soaked because it's all black, it's opaque, nothing to see there. But when you take a look at the 4 fluids that we tested, the first one being naphtha, perc number 2, methylene bromide 3, and then halocarbon number 4, you could see that the naphtha is clear. There's something from the coal that's escaped into the perc. Taking a look at the methylene bromide, like it's obvious there's a lot of stuff that's leaving the coal sample. And then on the far right-hand side, looking at the halocarbon, it's crystal clear. So there's no residual minerals, chemicals in there whatsoever. So once we had the coal, we tested it for various coal quality parameters. If you take a look at the qualities in the table, top to bottom, pretty self-explanatory. The bottom one, the control sample, it was the exact same coal that was processed through an industrial plant, so you're comparing something in reality to lab-based results. So really, like, take a look at the ash, VM, fixed carbon, sulfur, all very, very similar. On the far right-hand side, you got FSI, HGI, very similar. Anybody who sells coal or wants to sell coal into China, it's critical that you understand your trace elements. There's 5 of them right now since January 1st, 2015, that have been flagged by the Chinese government. And if you don't pass their criteria, your cargo could get quarantined. In this test here, we tested chlorine and fluorine. The other 3 would be phos, mercury, and arsenic. What we did in this run here for the first time, because we were unaware of it historically, we washed the coal in the fluids, and then in order to get fluorine results, for example, that were close to reality, we washed all the coal with acetone. So we'd never done that before. And if you take a look at fluorine compared to the real world sample, it's actually pretty close. So we're pretty happy with those results. We were very surprised on the chlorine side that, I guess if you look at the very bottom here for the control sample in chlorine, like not only did it take the chlorine out of the fluid, it was taking chlorine out of the coal itself, which was like totally unexpected. So we were surprised by that, and we are going to continue to look at that and doing further testing on it. But yeah, again, very surprised with that. Taking a look at fluidity results For these core samples, again, same order, control is on the bottom. When to take a look at these, DDPM, fluidity, certainly important. Always look at the temperature range as well. In my view, that's the most important quality criteria to look at in the Giesler test. That will show you the range, the temperature range of the coal, where it softens and resolidifies. So that's really going to tell you the opportunity for a coal to coke. And you can see that it's all very, very close, so those results are extremely encouraging. On the bottom half, taking a look at dilatation, contraction, again, the results from the different fluids and the halocarbon was very, very similar to the control sample. So what we did after testing those, we combined the coarse coal with the fine coal, got the clean coal composites, and really did the exact same thing. Going across from left to right, the ash in the clean coal sample from the plant is a little higher than the lab-based scale tests. In my view, that's very, very typical. That's common. With the processing plant, you have mechanical inefficiencies that you do lose some ash that where everything else in the lab is perfect, so you're going to strip more material out of it. So those results are very, very typical. VMs bang on, fixed carbon, sulfur, FSI, everything else here across the board actually looks really, really good, very similar. Again, taking a look at the trace elements, same thing. First column we have is the as-is, including the fluids that are attached to the coal, and then rinsed. So again, super happy with the fluorine results. Again, you're stripping more chlorine than anticipated with the fluids and the coal. On the fluidity side, little interesting results here. So DDPM of 80, temperature range of 68. You can see the fine coal had some decent rheological properties. When things were blended together, certainly lower than expected. Don't truly understand why. This is just one data point. I'm personally not concerned by it. We're going to have some recommended next steps just to follow up on that piece there. But yeah, interesting results, and we will confirm with further testing going into 2024 to see what the trend is. Same as on the dilatation side, you got contraction, very similar. Dilatation is different. So there was a 2.5-month delay in testing the clean coal sample from the plant versus the lab results. That may be part of it. The rest of it's a mystery. Sometimes in a lab you do have mysteries that you can't explain. But again, we'll continue to look at that quality parameter in detail going forward. Taking a look at the mineral ash analysis, everything is virtually identical. I'd make the same comment looking at the iron, so it's slightly higher in the processing plant. Again, I'm going to say that's magnetite getting lost in the wash plant and going into the clean coal product. So that's not an issue of any of the process here. This slide here is going to show the yield in ash. So when we take a look at the halocarbon product versus the PERC, everything was done in duplicate, and the results are very, very similar. So as a processing engineer, geologists, you're going to be certainly encouraged by these repeatable results in these wash curves. Finally, on the quality side, I'm not going to say the most important, but the CSR, the coke strength after reactivity, in all 3 samples, you got really, really good prime hard coking coal. There's like 0 impact to coke quality. Repeatability of this test is 3.3, so in my view, all those results are absolutely identical, which is great to see. So in conclusion, the quality results after the post-soaking looked really good. The clean coal procs, again, looked really good. Trace elements, as discussed, fluorine was very encouraging. Chlorine, we're going to do some additional studies on it. Rheology, post-soak, results look good. The clean coal composites, a little different, but again, we're going to confirm with additional testing. Mineral ash analysis, perfect. ash yield curves, really good. And the CSR, really good. So next steps going forward here into the future, we're actually going to do a soak test with acetone. None of us have ever done that. So out of curiosity, we're going to see what we get. So that's going to happen in February. We are going to do an elemental analysis of what was remaining in those fluids, where chlorine is clearly there, but like what else is getting lost in those fluids. Intention is to publish a paper in April. And then finally, we would like to repeat the entire procedure with using coal that has higher rheological properties. There's some in Canada that we could certainly source. There's some internationally that we could certainly source. Could understand there's questions about rheology, and I think it's important and prudent that we do get a coal that has higher rheological properties and test it and see what the outcome is. So in general, everything that we've seen using this halocarbon fluid for float sink tests is looking really, really good, really encouraging. So now I'm going to kind of go off tangent briefly and talk about what I'm going to call the Western Canadian halocarbon product. I'm going to say the one that you are all much more familiar with. So I'm going to say halocarbon. And then halocarbon. And I wish I had one of yours, Mike, but halocarbon, could have used it, right? So Mike did a great job earlier today talking about coal. I share the exact same view. So this piece is going to be a lot shorter. I think, in my view, like everybody in this room working in coal, we're making the world a better place. And that's never in the news. The coal that we mine, that's used for making steel, it's helping drive that green transition, right? There's steel going into windmills. There's steel in the rebar that goes in the foundation of those large windmill structures. There's going to be a huge transition in India. We see it. People in India want to go from a state of poverty to middle class. They want to have exactly what we have. And you could see the coke batteries getting built. You see the blast furnaces getting built. Coal's not going anywhere anytime soon. In my view, it's a scarce resource. I think all of us in this room should be proud of what we do, to be honest. And yeah, look forward to working with everybody going forward and advocating on behalf of coal, because it's never in the news. Last time I looked at projects in Australia, there was 15 projects on the go, one of which was hard coking coal, and the odds of that project coming online is essentially nil. Same thing, unfortunately, we're seeing in Canada. Like, it's tough for all of us. So scarce resource, super important. Hopefully there's a transition in the next couple of years with changes, I'll say, politically. There is more, I guess, advocacy on the government side, but yeah, I have no carbon guilt. I love coal, and it makes us all better in society. So thank you very much. Happy to answer any questions.
Thanks, Jason. That was very interesting. I'm going to start on the more granular, because once we get on to the coal is great, we'll then go off to lunch while we do that,
Sure.
because it is good. Just on the very granular side, very interesting research. That chlorine issue was a kind of out of left field.
Yep.
Is it possible? Can you use those liquids for everything you need them for, and then just do a workaround on the chlorine, like just work with the raw sample rather than run through those samples, or just get your chlorine out otherwise and then use the rest?
There's different means. So we've done some research in the past collectively, right? And I do have to mention that this is a huge group effort, right? It is UBC that's working on this. It's GWIL, Berkeley Lab in Calgary, working on this. Halocarbon, thankful for them for providing the fluids, and the CCRA, which I am part of, which is Canadian Coal Mining Companies, and steel producers, right? So you got AM in there, you got Stelco, Algoma, Chemet Energy, the federal government research. So there's a lot of folks working on this. So to answer your question, we've done research historically together as a big group from this Robin jig, which is water-based. So if you wanted to get a specific chlorine test, that would be an alternate lab-based route that you could do that. There's pros and cons to everything in life, and right now that's one of them, but we'll look at perhaps different fluids for rinsing.
So this is a promising technology. What you've just described in terms of who's collaborating, it sounds like this is going to be the direction.
Absolutely. It's clearly working and super safe, most importantly. Nobody wants to put anybody's health at risk for, I love coal, but nobody should be dying over coal either.
Questions from the floor?
Yeah. My name is Dave Osborne. We've met.
For sure. How's it going,
Nice
Dave?
to see you again.
Yeah, good to
I've
see
just
you.
moved back here to Canada from Australia. So I'm fascinated by this because you and I have had this connection with the jig, first of all, which we're interested in Australia.
Exactly.
We are scared in Australia in having to continue trying to protect ourselves from using organic liquids to do float sink tests. And we don't want to use heavy media mixtures. So the ROM jig provided an alternative. What you've now done provides, I think, a long-term option, that will eventually create a lot of interest worldwide. And we have a lot of projects that we'd like to get going in Australia. I'm kind of halfway between being a Canadian and being an Australian right now.
Yeah.
So I can see a lot of the things that are being described. I've been to 10 conferences in the past year and heard the same thing in Australia. And these are problems that we need to solve to give people comfort, when they're developing a project that we're going to do it properly. And it is a very effective test, but I think we've talked about collaboration with the Australian group, the Australian Standards Group and ACARP and the Australian Association Coal Research Program to do the same sort of work and work together on it. Because I think it will eventually create huge appeal globally. And I really would encourage you to do some tests on some lower ranked coals,
Correct.
a lot of thermal type coals, where you've got much higher volatiles and critical soft coking coals, in the middle that have much higher fluidity properties, just to prove to people that they actually can be confidently tested using this kind of float sink approach. So I really congratulate you. You've brought it this far. Now it becomes a global thing for global standards committees and mining companies that operate outside Canada to really start to look at and adopt.
Yeah.
Well done.
Thank you very much, Dave. I could say that there is initial discussions going back and forth between Canada and Australia, and we'll be working through Halocarbon. Hopefully there's the intention that the CCRA and ACARP are going to work together on this topic. There's been some work that happened probably 15, 20 years ago, but we're hoping this is the next one because, again, it's important for all of us. Yeah, thanks, Dave.
Hi, Jason. I'm always happy to learn something new. That's the highest CSR that I've seen with a lowest dilatation.
Correct.
I don't know if I missed this at the start. Did you tell us which coal this was?
It originated from the Elk Valley, I will say. Western Canadian coal. So I wear two hats, CCRA, Director of Technical Marketing for Tech Coal. So it is my job and my team's job to work with customers when you compare all Western Canadian coal to Australian coal, US coal. Rheological properties are lower, yes, but it still makes great coal, right? So based upon history, that's our biggest challenge. But I can say with confidence that on its own and in blends, it cokes really well. Western Canadian coal is different. You don't need the same rheological properties as you do in the US and Australia. So for example, there was work that Ross Leader did probably 10, 15 years ago, and he's
Yep.
part of this as well. If you want to make a great Coke with American coal, DDPM has to be a minimum of 600. If you want to make a great Coke with Australian coal, DDPM has to be 135 or greater. And if you want to make a great Coke with Western Canadian coal, like 10. So totally different, scares a lot of people. I could say from experience, our job is to convince the customers to use our coal. And I've had customers in the past 5 years just say, your coal is very peculiar. It shouldn't work, but it does. And they buy it to this day, so. I agree it's low, but it's still wonderful.
Definitely wonderful. Mike?
Hello. If you want to make a great Coke with bourbon, use Woodford
You're my
Reserve
man.
special batch. Can you just explain? I'm new to coal, obviously, because when I hear Coke, seal's the first thing I think of. But just what you mean by rheological properties, because I'm a little bit hazy.
The rheological properties. So it's a measurement. There's different tests. So as a coal in the coke oven heats up, and typically, like I'll go back here and I'll show you the numbers. Right here. Let's use the bottom one. So that specific coal starts to melt at 432 degrees, and then it's soft until 464 degrees. So it goes into this plastic phase, where it goes from a solid to a plastic phase. That's where VM's driven off. That's where it mixes with the other coals in the blend. So it goes from solid, plastic, back to solid, and you start to get your Coke transition. This test here gives you that range where your coal could play with other coals in a blend, and it's going to make Coke. That's actually a real number, in my view. The DDPM, for historical reasons, I get it. The DDPM is dial divisions per minute, so it's not really a material test, but it's a test that's recognized in the world. So what happens is coal goes into a cylinder, and then on the cylinder it's got like a little, I'll say, piston sticking out the side. They heat it up, and then as it gets soft, it starts to spin. So there's 100 dial divisions in 1 DDPM. I'll go to the extreme, like a US coal could be as high as 64,000. So they heat it up and it's just like water. Where Western Canadian coal is more viscous. So when you get a DDPM of 80, it's not even doing one rotation in a minute. It's just kind of going through the plastic phase and stopping at 80 in 1 minute. So it gives you an indication as to how soft it is, but truly that's the material numbers that I look at. That tells you it's going to Coke.
What are the buyers looking at?
It depends on geographically the region. So there was a famous paper that came out of Japan in the 1970s that said your blend has to have a minimum DDPM of 200 or it's no good. That was totally valid for the coals they used at that point in time. Again, when it comes to Western Canadian coals, we've had customers, putting my tech hat back on, that used 100% tech coal. And they made great Coke. So there's still people that will go back to that paper from the 70s. That's the way they were taught, that you have to have a DDPM of 200. And again, that's historically been one of our main challenges in Western Canada, is convincing people to use our coal with low DDPM. I think we've won the battle. We sell lots of coal into the newest market for us. It would be India now, and they accept it. As we expand into new markets, that question is going to come up, and we just have to convince them with data that it works. So geographically, I've gone to China, and I say DDPM, they don't even know what the hell it is because they use different, they have GB standards, right? They don't even test for DDPM, so it depends where you're at.
So again, just being new to coal, I've got a great team who aren't new to coal, but I am. So in iron ore, in the fines blending that they do in the sinter strand, because that's one thing I did do,
Yep.
it's a real mix, it's a real cocktail. Is it similar with coking?
It can be. It depends, again, on geography, I would say. Everyone's going to be going on costs. They're going to take coals that are closest and cheapest. That's to their benefit. So it varies. Some folks, it depends on their risk. Some folks use 6 coals. Others have like 15. They want to have diverse supply strategically, which makes sense. I get that view. So it varies.
The really sophisticated buyers have an elaborate linear programming model. It's got all the inputs in there, and it spits out, this is my most economic cost of producing Coke. But then the technical guys go, yeah, but don't make me use this one because we actually haven't used that for a long time. Yeah. And you're happy with the Coke that I'm making now, don't make me change. And then our job as marketers is to prove to the technical people that, in fact, if you use this product, you're going to be very happy and you're going to save money.
Yeah, exactly.
Have I got it right, Jason?
And the blast furnace is happy, so they're not phoning you.
The blast furnace is a demanding taskmaster, and
Correct.
the coke oven people definitely never want to disappoint the blast furnace.
Correct.
So those are the people you got to convince.
It's always flowing downhill. But our job is to convince them to use it.
And Western Canadian Coal does a great job, so it's not as hard as it might seem.
Absolutely.
And just to take that blending scenario backwards into the pit, any of these pits that we're dealing with here in Western Canada have multiple seams, and every seam is going to be different. So it's up to the pit operation to figure out what your seams are like. How do you blend them going into the plant? And then these guys have to figure out, coming out the other end, what do they do with it?
We still got time for a question. Any more questions for Jason? And hats off to CCRA. CCRA was one of those foundational groups that actually proved to the world that Western Canadian coals would work well, including CanMet. CanMet was part of that as well. So yeah. It's been a great job. I hope you're enjoying your time there, and thank you for your service.
Love every second of it.
Well, that wraps it up. Jason, thanks. Please join me in thanking Jason for an excellent talk.